in physics fire. So as we had done last class about motion under gravity, so we finished almost everything. 1-2 questions are remaining that we will do today. And apart from this, in today's lecture, we are going to see what is relative velocity, numericals related to that. Interesting topic. Let's see. So first we'll do 1-2 numericals related to what? Motion under gravity. After that we are going to see relative velocity. Fine. So the first thing, if you will see the numerical which is there, okay, if you'll revise what is that motion under gravity, then it comes with what as we learned, the first thing is what, anything if you are taking it above the ground, right? Above the ground is what, any velocity difference height. If you are taking this, then above of that, anything is going before above of that, right? Suppose u, that will be what, positive. Acceleration due to gravity, that is the exceptional case, always be negative. I will tell you why. And the height, if you are taking above the reference height, then it is going to be what, positive. If it is below u or v, it is below, v is also what, above, then what, positive. If it is below, then what, it is negative. U is what, u is negative, v is what, negative, right? And then what we can say, height is also what, negative, right? Acceleration due to gravity, as we've learned, that always it is what, negative. Okay, why it is always negative? Because always if you will see that if you'll throw an object, anyway it will come down, right? If you'll leave an object, anyway acceleration will be what, downward only, right? So we can say always it will be downward only. In these all numericals in motion under gravity, we can use acceleration is equal to what, minus of g, which is 10. And then we can say one more thing. Actually, in class we will take 10, right? 9.8 also you can consider, but for easy calculation we will consider what, 10 only. And one more thing we are supposed to know here, that we can use all the equations of motion under motion in motion under gravity. Why? Because acceleration is constant. Whenever acceleration is constant, then we can consider all those formulas. Example, v is equal to u plus at, s is equal to ut plus half at square, v square is equal to what, u square plus 2as. So on like whatever the formula is required, by seeing the numerical, whatever the given data are there, those all things will check, and then according to that we can use the acceleration due to what is that, the equations of motion, right? Let's see now. The first question is what here, a ball is thrown upward at a speed of 28 meter per second. So guys, u is what here, 28 meter per second. U is 28 meter per second, right? Fine. Find the speed of the ball 1 second before reaching the maximum height. Time you leave now. Maximum height, at maximum height guys, v should be what, equal to 0, obviously, right? And then we don't know the time. What we are seeing here, let's consider like this is the maximum height, so h maximum, right? So till v will be what here, 0. U will be what, u is given, anyway a will be what, minus of g. Guys, now we can do no, v square is equal to u square plus 2, or v is equal to u plus 80, so that we'll get the total time, right? See, now the concept is what here, find the total time first. Then what, suppose if this takes like suppose 3 seconds from here to here, right? Then 2 seconds will be somewhere here, right? Before 1 second reaching the maximum height, it means 2 seconds will be somewhere here. So that time we will take, and then we will get whatever the maximum height will be there, right? So before a ball is thrown at a speed, find the speed, right? At 1 second before we can find the speed. So our goal is what, now to find the time for the total path, right? So let's see now. Now we can say here v is equal to u plus gt. Anyway, v is 0, u is what guys, u is 28 minus of what, 10 into what, time. So we can say t is equal to how much, this will come this side, so 2.8 meter per second. Okay, the question is before 1 second, so t final is going to be 2.8 minus of what, 1, so 1.8 second, right? 1.8 second, you understood, right? Now what we are supposed to find? We are supposed to find the speed. Okay, what is the final speed ultimately, right? Then we have now v is equal to u plus at. Now we don't have v, right? At maximum height, final velocity is going to be 0, not before 1 second. That's it. V is equal to what? U plus what? Gt. V is what here, guys? V is we don't know, we want to find, right? U is what here? 28 minus of what? 10 into what? Time is 1.8, so it is going to be 28 minus of 18, so we can say 10 meter per second. That is the final velocity. That's it. Hope so you guys got it. Easy, right? Next question is really good. A tap drops water drops at 1 second interval. Find the distance between the third and the fifth drop when sixth drop is just coming out of from the tap. Okay, when sixth drop is just coming out of the tap, right? So let's consider this is the water tap, right? From here water is coming out. Let's take this is the sixth drop, right? Then it will be what? Fifth drop. Then it will be what? Fourth drop. Then it will be what? Third drop. So from here to here 1 second, from here to here 1 second, from here to here 1 second, right? Fine. So now if you look for a third drop, right? So we can say no, the height, if you will see here, okay, let's leave first. We'll see what the third drop, if you will see, right? Third drop, then for third drop u should be equal to what? Obviously 0, right? And then acceleration will be obviously minus of g, that is minus of 10. Time is how much, guys? 3 seconds, right? Okay, now let's find the distance, right? From here to here, what will be the distance? That we will find first, because they're asking third to fifth. Okay, let's take this is what? H3. So now we can say that s is H3 is going to be what? That we will find, right? We can use the equation. What is the equation? We want to find the height. S is equal to ut plus half at square, right? S is equal to ut minus of gt half gt square. U is what here, guys? 0 minus of 10 into what? T square. T square is what? 9, right? 3 square, so 9. It is going to be 5, so 45. S is equal to what? Minus of 45. Why minus of 45? Because before, like below the reference line, that's why negative. Fine, no problem. Now we can say that what? For the fifth drop, for the fifth drop, if you will see, what is u? Again 0, right? Anyway, a is how much here? Minus of 10. And then what we can say? Time is how much here? Time is 1 second, right? Time is what here? 1 second. Then again s is equal to ut plus half at square, ut minus of half gt square. T is what here? 1 square, and that is going to be 0 minus of what? Minus of 5, right? Is equal to what? S is equal to what here? 5 meter. That's it. No, guys, if you want to find the final, like what will be the height difference, then we can say this is minus 45, this is what? Minus 5, this is 40. Fine, anyway, whatever you write. Then we want to find the difference between them. Difference between them is what? We can say this difference, 45 minus of 5, right? Ultimately, so that is going to be what? 40 meter below. That's it, right? I hope so you guys understood, right? And now let's say relative velocity, relative acceleration, relative displacement. This all topics. See, if you will see motion, that is also a relative term. With respect to what? Because the whole earth is moving, right? Because the whole earth is moving. So whenever you are talking about motion and all, because whenever in the starting of the chapter also we learned that what? The whole earth is revolving. If the earth will revolve, then whatever the things are there on the earth, inside the earth, everything is revolving. It means I am also moving, right? I am also in motion. With respect to whom? One who is outside the earth, not inside the earth. One will be in earth, no problem at all. But one who is outside, right? One who is observing from outside, then you will say, of course, he is also in what? Motion. I am also in what? Motion. So relative, if I am in motion, then I have velocity, right? Again, the problem comes that what? Relative velocity we know. Now the term relative, if you will see, suppose a bus is moving in this direction, right? And then one who is inside the bus, and one guy is what? Outside the bus. He is observing the bus. So what? two people are observing. Let's consider one is inside the bus, one is in one like the bus is moving, one guy is going like he's just in the bus stand and the bus is moving, and one guy is inside the bike in bike, he's riding a bike. Both guys are observing. Now one who is observing from the bus stand, it's the bus velocity will be different. One who is on the bike, the bus velocity will be what? For both of them, bus velocity will be what? Different. So it depends like with whom you are, like from where you are observing, who is observing, that depends, right? It does not mean that what velocity is changing of the velocity of the bus will change, but the problem with respect to whom you are observing, due to that it will change. Fine, hope so you guys understood. Even if you will be in train, right, your train is in a state of rest, and then one more train is there which is moving, so you will feel that my train is in motion, that train is at rest. But actually what happens? Not like that, right? Even same thing, if you will see from outside, if you will see from train, then whatever the homes, trees and all, when your train is with a speed of like 60 km/h, it seems like that the whole earth is moving behind, right? Which is not possible. Again, it means your train is moving because you are on the train, so you are feeling that you are at rest, and the whole world is what? Moving. Fine. That is what we say relative velocity. So in short, we can say relative velocity is with respect to what? From where we are observing. That's it. If you understand this, that's okay. We can do any questions. One more thing, for relative velocity, whenever you are solving any numerical wise, how you should solve, whenever we are solving any numericals, then we should consider the ground, like frame of reference. Suppose one bus is there, one guy is in motorcycle, right, one is in flying, so everyone, like 2-3 objects are there, then every object should have only one frame of reference. If it is air, then air. If it is ground, then ground. If it is water, then water. That's it. If you understand these things, relative velocity almost we finished. That is what relative velocity will come. Fine. It means what I told, again I am repeating, for relative velocity, if you want to solve numericals, then we should do is what? Only one ground we should choose. Like with respect to what? Ground, if you are considering water, then only water. Land, then land, right? Air, then air. Everything should be with respect to what? Land. That's it. Or air or water, anything. Fine. Now the relative velocity, hope so you guys understood. Now relative velocity, if you want to write, suppose bus is moving in this direction, right, with some speed v. Let's say va, one guy is here, b is at rest. So somebody is saying B is observing A. B is observing what? A. So what we'll write? Velocity of A. What is that? Velocity of A with respect to what? B. So velocity of A with respect to ground, because both things are in what? Ground only. Minus velocity of B with respect to ground, right? So this thing is important. Only one frame of reference. Ground, that's only ground. Bus, then only bus. That is important here, right? We understood that what? With respect to whom you are observing, that you should do. That's it. Let's see one example. Suppose one guy is there, this trolley is in motion. This trolley is in what? Let's consider this trolley is moving with 20 meter per second. You are supposed to find velocity of A with respect to B. Velocity of A with respect to what? B. Let's see, velocity of A with respect to B, right? So what we will say, velocity of A with respect to ground. See, initially you should write the steps, then only you understand properly. Velocity of A with respect to ground minus velocity of B with respect to what? Ground. Velocity of A with respect to ground is how much? Velocity of A with respect to ground is what? 20 anyway. Velocity of B with respect to ground is what? 0. So 20 meter per second. Now this B came here anyway. All the way he came here only, right? If B will come here, then we can say velocity of A with respect to B, velocity of A with respect to ground minus velocity of B with respect to ground. Both are moving with 20 meter per second, right? So 20 minus of 20, it is going to be what? 0. Now see, the same guy, one who was outside, different, one who came inside, different, right? Okay, so that is what relative velocity. Now the question is what, two persons are there, A and B. B is moving with 10 meter per second, A is moving with 20 meter per second in the same direction, right? When B observes A, what is the speed of A as seen by B? When B observes A, what is the speed of A as seen by what? As seen by B. As seen by what? B. Okay. So as seen, who is observing here? B. So velocity of B with respect to what? A. That's it. Velocity of A with respect to ground minus of velocity of B with respect to ground. Velocity of A with respect to ground is how much here? 20. Velocity of B with respect to ground is how much here? 10. So we can say velocity of B with respect to A is how much? 10 meter per second, right? The same question, if they'll say that when A observes B, when what? Let's consider, they can ask like this also, no? When A observes B, when A observes B, then velocity of A with respect to B. Velocity of A is how much here? Velocity of, we wrote wrong, no? This should be 10, right? And this should be 20. Correct only, no? Yes. Velocity of this, we'll have to convert. Wait. Sorry. Just a minute. Velocity of B with respect to A. So velocity of B with respect to ground minus velocity of A with respect to ground. Right? Now velocity of B with respect to ground is how much? 10. Minus of what? 20. Minus of 10 meter per second. Right? That will be the answer. Now velocity of A with respect to B is what? Velocity of A with respect to ground minus the velocity of B with respect to ground. So this is how much? 20 minus of what? 10. So 10 meter per second. Difference is there, right? Who is observing to whom? That also matters a lot. Now let's see what is the velocity of B as seen by A. Now both are in opposite direction but same track, right? Opposite direction but in what? Same track. Guys, again we can say velocity of B as seen by whom? A. So we can say now velocity of A with respect to ground minus velocity of B with respect to what? Ground. Easy. Now velocity of A with respect to ground is how much? 20 meter per second. Guys, this side if you took positive, then this side should be what? Negative, right? So we can say minus, right? Minus of what? 30, right? So ultimately it is going to be how much? 50 meter per second. That's it. 50 meter per second. So velocity of B with respect to A, velocity of A with respect to B is how much? 50 meter per second. Hope so you guys understood, right? Okay, another way is what? Who is observing? See, like short trick if you want to do, then we can do by this way also, short trick. Who is observing? Velocity of B as seen by A. Just stop them. Stop that. Who is observing? A. Stop A. Then what you do is here, whatever the velocity of A is there, that you, like he's moving in this direction, you take the velocity this direction, add here 50 meters per second. In a second you can do. So what you are supposed to do, who is observing? Whatever the velocity he is having, whatever the acceleration he is having, that acceleration what you do, add on another one, and then what? In opposite direction, like same direction of that. That's it. By that way also you can do. Now see here, now there is a different type of question. What is the velocity of A with respect to P? Velocity of A with respect to what? P. Now the problem here, this is the trolley, right? Now problem is what here? So everybody will say velocity of A with respect to P. So velocity of A with respect to ground, velocity of P with respect to ground. Now the problem here is we don't have the velocity of A with respect to ground. We have the velocity of A with respect to the trolley, right? So we'll have to find first this thing, right? Hope so you guys got it. What is that? Velocity of A with respect to trolley is given, but velocity of A with respect to ground is not given, and we want to find that. So let's find now velocity of A with respect to trolley. We'll have to find. So velocity of A with respect to ground. Velocity of A with respect to ground minus a velocity of trolley with respect to ground. So velocity of A with respect to ground is how much? 5 meter per second. Velocity of trolley with respect to ground is how much? minus of 20 meter per second. So velocity of A, velocity of A with respect to trolley is how much? What I'm doing? Velocity of trolley with respect to ground is how much? Velocity of A with respect to trolley is 5. This we want to find, right? And then minus of what? Let's take X. Velocity of trolley with respect to ground is 20. This side it will go. Then 25 meter per second is X. So we got this ultimately, right? Now velocity of A with respect to what? P is going to be, velocity of A with respect to ground is 25 and minus of what? 20. So ultimately it is 5 meter per second velocity of A with respect to P, 5 meter per second. That's it. Now there is another set of question. Find the time at which the police caught the thief if the speed of thief is 10 meter per second and police is what? 20 meter per second, and the distance between them is what? 100 meter. Guys, ultimately here if you will see velocity of let's take, he is the thief and he is the police, right? Okay, so velocity of, now we'll have to find everything. Who will catch the thief? Who will catch the thief? Police only, right? So now we can say, now what is that? Velocity of police with respect to thief is velocity of police with respect to ground minus velocity of police, velocity of thief with respect to what? Ground. Velocity of police with respect to ground is how much? 20 meter per second, and this is what? 10 meter per second. Velocity of police with respect to thief is how much? 10 meter per second. That's it, right? That we found the velocity. Fine. We have the distance also. Distance is how much? Velocity of distance of police with respect to thief is how much here? 100 meter. Everything should be there. Velocity of police with respect, like velocity, displacement, same thing we should have, right? Now they are saying that what? Find the time at which it will get caught, right? Find the time at which it will get caught, and the speed of the police is 10. Time, if you want to find, time is equal to what? Distance by velocity. Time is equal to what? Distance by velocity, right? Same, no? PT for velocity also, PT for distance also. So by what? By 10. So we can say time is going to be 10 seconds. After 10 seconds he'll get caught. The police will get what? Caught. Now they'll say at what distance it will get caught. S is equal to distance into time. 100 into what? 100 into 10. So velocity is how much here? Velocity is 10 only, no? Velocity is 10. So after 100 meter it will get caught. That's it. Wait. No, 100 meter you found, right? 100 meter extra you will have to run. So ultimately the total distance is going to be how much? 200 meter. Because 100 meter the police will run extra, and 100 meter ultimately the distance is there. So that you will cover after that 100 meter. So ultimately 200 meters. Fine. Now what is the time and the position when thief will get caught? Now acceleration is given, guys. Easy only, right? Let's see now. 150 meter is the distance. Now velocity of police with respect to thief. Velocity of police with respect to thief is what? Velocity of police how much here? 20. Velocity of police with respect minus velocity of thief with respect to ground. Remember that. Velocity of police is how much here? Velocity of police is 20. Thief we don't know. So 0. So we can say velocity of police with respect to thief is 20 meter per second. Now acceleration of police with respect to thief. So acceleration of police is how much? 0, and that is what? 1 meter per second square. So we can say acceleration of police with respect to thief is minus 1 meter per second square. Okay, that we got. And then we can say displacement of police with respect to thief is how much? 150. Now S we have, A we have, velocity we have. See guys, only one thing I am doing is what? All should be in the same frame of reference. That is most important point in relative velocity. That's it. Now we can say that what? S we have, acceleration we have, velocity we have, and they're asking what is the time. S is equal to ut plus half a t square, right? That also you can do. S is how much? S is equal to ut plus half a t square. U is how much here? U is 20 into what? Time plus what? Half. into minus 1 into what? T square is equal to what? 150. Calculation is there. Fine. So we'll have to do anyway. 20t minus of how much here? Minus of t square by 2 is equal to 150. If you'll solve here, time value is going to be 30 second and 10 second. Time value is going to be how much? 30 second and what time value is 10 second. Guys, if it will catch at 30 second, why it will go for 10 second? If it will catch, then why it will go for 30 seconds? So after 10 seconds it will get caught. Now they are saying that what, how much is the distance it will after 10 second, where it will go ultimately. So that also we can say, right? Position now you can also find. So these types of questions they will ask in the relative velocity. Okay, let's check once. You guys check it properly. You know, this is what I did. Position you guys can find by yourself, right? Fine. So till here you guys revise this topic. We finished this relative velocity. 2D we haven't finished, relative velocity in 2 dimensions. So that also I'll do. That's it. Then we'll start some other topic in this chapter. We'll see.